Hello everyone, myself V.V.Gopala, Assistant Professor, Department of Computer Applications, Aditya University. Today I am going to lecture on error detection using CRC. In the earlier sessions we have seen, so what actually the meaning of an error and what is the role of error detection and error correction. There are several methods or operations to find out if any error is occurred during transmission, so you can able to identify whether error is occurred really or not, where it is actually happening and how to correct it. So these are the things actually we have seen by using certain procedures. Now today I am going to tell you about CRC. The full form of CRC is cyclic redundancy check, which is actually following the concept of cyclic code. So today after completion of the lesson, so I am expecting the outcomes which are actually introduction to cyclic codes, what actually the meaning of a cyclic code and what is CRC and how do you find out CRC, and also what actually the role of a syndrome in the CRC procedure, and also finding the CRC using polynomials instead of using a binary code. You can also use the polynomials to find out the CRC value. So that is why these are the outcomes we are actually expecting after completion of the lesson. So let us proceed for the first point, that is related to what actually the meaning of a cyclic code. Suppose you have a data to send. So the data is generally in the form of a binary notation. Let us say you have 1011. So it is a binary data. So you can transmit the data in the form of bits from the sender to the receiver by using a medium. So during transmission, any one bit or more than one bit may be corrupted. Corrupted in the sense it may be altered. One may be altered as 0 or 0 may be altered as 1. So whenever this is happening, it can be considered as a corruption. In our terminology, it is called as an error. So if error data is there during transmission, then the data, if you accept it, so it is of no use. So that is why we have to first of all find out whether any error is occurred or not. If no error is occurred, you can accept the data. If any error is occurred during transmission, you can reject the data. So that is the actual policy we are actually expecting in this case of the error detection and correction. Now in that there are several concepts, but here cyclic code is a different one, where the bits are rotated in a predetermined manner. They may be rotated in a left side direction or right side direction. So that is why this code is called as a cyclic code. Suppose you have a data called 1011. Suppose if each bit is rotated left bit one position, then you can say that this 1 will come to this. The rightmost bit will first of all move to the preceding position, and this one is able to move to occupy the position which is actually occupied by 0, and this 0 will occupy the position of 1, and this 1 will occupy the vacancy of the most significant bit, that is in the rightmost side. So if you see that, then the resultant may be like this: 0 1 1 1 is the new code we are getting. This code is generally referred as a code word. So you start with a data word 1011. Because of cyclically shifting the positions one bit left side, then we are able to get a new word, and that word is called as a code word. So this is actually the process of cyclic codes. So the code word is going to help whether any whether any error is occurred or not. You can able to identify based on the help of the code word. We will see what actually the CRC is going to help us. We will find out in the procedure. So as I mentioned, one more example is shown here. Let us say this is the data word. So here 7 bits are there. In that one position is leftmost, the left side one position is shifted, so that we are getting the new word. We are getting the new word like this. So this is called the code word. So this 0 is actually moved like this, like every bit is transferred to this new position, thereby you are getting a new word that is called a code word. So, now how the code word is actually affecting or finding out the error whether it has occurred or not. So, let us say there is a main concept where sender and receiver are using respectively encoders and decoders, and here the encoder is following certain steps to get the code word, whereas the receiver is taking the help of the code word, is going to give you an idea whether the data that is received can be accepted or not. So, let us take that the data word is taken on the top, which is in the form of bits. Let us say that A0, A1, A2, A3 are 4 bits. So, they may be of any value, where all may be zeros, or there can be number of combinations you can imagine, and these data word is now allowed to a generator. The role of generator is to generate redundancy bits. So, this R0, R1, R2 are the redundancy bits based on the data word that is allowed for the generator. The role of generator is to generate redundancy bits, so that the data word, that is A0, A1, A2, A3, and the redundancy bits that are generated from the generator will be clubbed together, and this total word can be referred as a code word. So, this is the way how the code word is actually generated in the encoder at the sender side. So, this particular R0, R1, R2 are nothing but the remainder values. We will see in the process how the remainder can be obtained and what do you call the remainder. Those things you can able to identify in the example or in the next step. So, this is the way how the code word is actually generated, and this code word is transmitted to the receiver. The receiver is actually using the code word, but of course, the code word is renamed as B0, B1, B2, B3 and Q0, Q1, Q2 to avoid confusion. So, this particular notation is followed, and this code word is actually allowed for the checker. The checker is going to follow the procedure what actually the encoder is followed at its end, and it is going to generate a syndrome here. This syndrome is nothing but the remainder what actually we have seen here at the generator side. Similarly, here also we are going to get the remainder here, and that remainder is here referred as syndrome. This syndrome is allowed for the decision logic, and this decision logic is going to decide finally whether to accept the data word or not. Suppose this decision logic is going to display the syndrome value as 0, then this particular the data word that is in the transmission can be taken into consideration. It can be accepted when the syndrome value is 0. Suppose the syndrome value is not 0, it is non-zero, which is allowed for the decision logic. It is going to give a decision. Don't accept, better you discard the data word which is in the transmission. So, that is the actual the process at the receiver side by using a decoder, and already we have seen the process at the encoder at the sender side. So, this is the main criteria we are going to find out here. But here one important thing is in the sender, encoder and the decoder at the receiver. So, both should follow a common divisor which is indicated as D0, D1, D2, D3. This is a very important thing. Both sender and receiver has to follow the same divisor in the entire process. Now, we will see how the thing will happen. Okay. So, let us consider that there is a data word which is 1001. So, that is a data word. We start with the data word, and the common divisor is 1011. This is the common divisor. Okay. So, this is to be identified by the sender and receiver. So, this is a common divisor we call. So, now you see that this divisor is common and the data word is 1001. So, in the process, so if you count the number of bits in the divisor, it is coming to 4 bits. So, in this data word, 3 bits are to be added. That means less than the number of bits that are available in the divisor, less than 1 of the count. you have to add that many number of zeros to the data word. Now it comes to 3 because the divisor is of 4 bits, less than 1 means it should be 3. So 3 zeros are added. Suppose data word is 5, then suppose divisor is 5 bits, then you have to add 4 zeros. If divisor is 3 bits, you have to add 2 zeros. So it is purely based on the size of the divisor. Because of 4 bits, you have to add 3 zeros at the rightmost side to the data word. Now it is coming to 1001 and 3 zeros. So this is the actual data word we are starting with in the encoder, and this should be divided with the divisor, common divisor, that is predetermined by sender and receiver. Now you have to follow the division procedure. In this let us say it is going one time. Now you drop 1011 here. You follow exclusive OR operation here. So whenever both are of a similar sign, so better you put 0. If both are of different sign, you put 1. So that is actually the exclusive OR operation. So here it is 0 and you drop 0 here. Now because of the leftmost side you are finding 0. So this is the thing what you have to remember. So because of the leftmost side you are finding 0, you have to drop all zeros. You put 0 here and 0 multiplied by these bits, again you get all zeros. So that is why you are getting this. And again you drop one more 0 here. And because 1 is here in the leftmost side, you can put 1 here. So one time it is 1011. So this is 110. Because again the leftmost side is 0, you drop 0 here first of all and put 0 here, and 0 multiplied by the divisor, so you are getting all zeros. So again you follow exclusive OR operation, you find this one 110. So this 110 is called as the remainder, but technically it is referred as the CRC value. So the CRC is nothing but the value that is obtained after division as a remainder. That remainder is technically referred as CRC. So this CRC value will be replaced the initial zeros that are actually considered. Now the new code word will become like this. We start with the data word as 1001, but the remainder what we obtained is 110. This is totally the new code word that is actually to be sent in the transmission. So this is the way how the code word is indicated here. So that is about the process at the encoder. Now you see the code word is received by the receiver and there is a decoder. Decoder, we find two types of cases here. That means the decoder is going to find out when there is no error that is taken place, and also the decoder is going to identify when there is an error that is going to take place, whether to accept it or not, that we are going to find out based on the syndrome value. Now the same procedure is carried at the decoder also, the exact procedure what we followed at the actual encoder, but here this value is 000 in the encoder, but in this decoder it is 110 because that the CRC that is arrived at the encoder is now taken into consideration. This is the code word that is received by the receiver. The same procedure is carried out as we followed in the encoder, but here if you see that the syndrome or the remainder value that will obtain is 000. So this is called the syndrome in this particular terminology. So now whenever this 000 is derived, then you can say that because syndrome value is all zeros, you can consider this 1001, which is actual data part, can be considered as an acceptable data part. It is not all the cases. There may be some chance of 1 bit may be altered or 2 bits may be altered. In that case, if you see this particular case, let us say that there is this position is changed, this position is actually altered. Actually in the data the code word that is sent is 1001 110, but in the transmission the code word 1 bit is altered as 0. 1 is altered as 0. So again the same procedure is carried with this 1 triple 0 1 1 0, but the common divisor is there. With that, if you consider the same procedure, we are getting the remainder value which is a non-zero value, 0 1 1 we are getting. This is a critical part. Whenever we are getting non-zero syndrome value, we should not accept the data. The data should be discarded. So don't consider the data. So this is the process we can consider in the decoder. If any error is occurred or not, you can able to find out based on the syndrome value. If syndrome is all zeros, so no error is there, data can be acceptable. If syndrome value is non-zero, the data should be rejected. So this is the way how CRC is going to help us to find out error is occurred or not, whether to accept or reject the data. Sometimes the process can be also carried out by using polynomials. So this is the general equation of the polynomial. Let us take that x power 0, x power 1, x square, x cube, x to the power of 4, x to the power of 5, x to the power of 6. So there is a predetermined kind of a notation which is called as a basic polynomial in the actual polynomial representation. You can consider this is the basic representation of the polynomial. Sometimes the binary word can be expressed in the form of a polynomial. Let us say that, so there is a form of equation that is given, form of a polynomial that is given as 1 plus x to the power of 6. So from this you have to derive the binary word like this. How you can able to derive the binary word? Just you compare this polynomial, given polynomial with the general polynomial. Wherever you are finding the terms, there you put 1. Wherever you are not finding the terms, then you put 0 in that particular term. Suppose 1 is here, so 1 already it is there in the, if you compare with the polynomial, so 1 should be there. And next is x, x is here, x to the power of 1 means it is x only. So this next term is x, because x is here, so 1 is also here, because when you compare, the terms are actually matching, so that whenever matching is there, you put 1. Whenever no matching term is there, you put 0. Then immediately we are getting x to the power of 6. That means up to this there is no term when you compare with the polynomial. Then all the remaining positions are occupied with zeros. Only at the position x to the power of 6 you are getting the 1. So this is the way how the polynomial can be able to represented in the form of a binary word. Then the rest of the procedure is again the similar thing. As once you are able to convert the polynomial into the form of a binary word, you can follow the same procedure what we have seen in the encoder and decoder. Suppose you want to carry out by using polynomial. So let us say that this particular x to the power of 6 plus x cube is the data word, and 1 plus x cube is the actual divisor. Then you can follow the same process. Only thing you have to use the terms, the x terms, but process is same. That means if you see this, because the first term in the data word is x to the power of 6, because the first term in this divisor is x to the power of 3. So if you see the powers, it is 3 and it is 6. So now this x to the power of 3 can go x to the power of 3 times. So it is x to the power of 3 on the top, it is mentioned. This multiplied by the divisor should be dropped here. So it is becoming x to the power of 6 and x to the power of 4, because x to the power of 3 and x is x to the power of 4, and x to the power of 3 into 1, that is x cube. Again you just subtract. So because these are when you are subtracting, these will become negative signs. So this becomes 0. So now you are getting x to the power of 4 and you drop x to the power of 3. There is one more term that is called x to the power of 3, and because x to the power of 3 is here, and you take x into consideration, because it is x to the power of 3 and it is x to the power of 4. So x to the power of 4 can come after multiplying x cube with x. So that is why we are getting x multiplied by x cube plus x plus 1 is coming to x to the power of 4 plus x square plus x. So if you subtract, then x to the power of 2 plus x is the remainder we are able to get. This can be called as the actual CRC in polynomial notation. So that is why the process is same. You take the data word, divide with the common divisor, find out the remainder is called as the CRC, and that CRC should be clubbed with the data word, which can be called as a new code word, that will be sent to the decoder. Decoder is also going to follow the same procedure by using the code word, and it find out the remainder value, and remainder is called as a syndrome. If syndrome is 0, then the data will be accepted. If syndrome is non-zero, the data will be rejected. I hope you understand the process of CRC. So, I hope that this is the actual process or steps carried out in CRC. I think that you know about introduction to cyclic codes, what actually the meaning of CRC, and how do you find out CRC, and what is the role of syndrome. Syndrome is a very important area by which you can able to decide, after decision logic, you can able to decide whether to accept or reject the data. And also you know what actually the role of a polynomial, how you can able to convert the polynomial into binary word or a binary word into a polynomial, how you can able to carry out the process of CRC to find out the CRC value. Thank you.